Welcome back to another brainstorming session after a good lunch. In the morning session, we have heard about CIP, CIP4, MIS, JDF, all acronyms. Acronyms used in today's digital binary world. But we have not yet moved away from a very analogous physical hardware or an accessory in our print production process of today. You guessed it right, it's the blanket. We have a fantastic CTP plate set. That is, we start with a fantastic dot. But is the dot on the paper perfect or poor? There is no one simple answer to that. Any experienced press operator will verify. But a good blanket is definitely essential, you would say. It's my pleasure to invite Thomas Gerlach from Phoenix Xtra from Hamburg, Germany. Thomas was born and raised and educated in Germany from the city of Hamburg. After an assignment with a supplier for the tunneling industry participation in a management buyout of Phoenix Xtra GmbH in the beginning of 2002. In a small TT with him, I asked him what tunneling has to do with blankets. He explained me the matter. He told me while tunneling, there is a process of boring the undergrounds, putting in rings of cement and sealing them with a rubber solution. That explains it. The rubber plays an important part there. So his company, that is Phoenix, are the blanket manufacturers, taking over of the sales and marketing management for India, the Middle East, Africa and Scandinavia. He looks after them all. Main projects since then has included setting up of several converting plants, installing sufficient dealer networks and implementing new blanket technologies in the region. So he will be helped in his presentation by Rajiv Shah from Xprint, Phoenix Xprint, India, when the need arises. So over to you, Thomas.
Okay, thank you very much for the nice introduction. Good afternoon to everybody. Ladies, I've seen a few, and gentlemen. I have the very difficult task to get you awake again after lunchtime. I'll try my best. If there's anybody who just wants a little nap, I don't mind, I would understand that. Okay, fair enough. All right, the introduction said it already. We are going to talk a little bit about blankets, about offset printing blankets. What a boring product that is. It looks like a floor mat. It looks like something anybody could produce. What I will try today is to explain you a little bit why it is so important to use a proper printing blanket, a good printing blanket, that looks the same like the sheet material as well. Yeah? How it affects your printing results, yeah? And how everything relates to each other. Yeah? So, a little bit about the contents, just quickly. Who is Phoenix Xtra Print? I just would like to tell you a little bit more about our current setup. Just briefly, what does a printing blanket do? What is it good for? Nobody ever really thinks about it. It's just a part in the production process, but nobody really makes up its mind about what it is really doing. Why it is so important. directly related to this issue. And can printers improve really the print quality with the help of the blanket, with the treat of the blanket, with the handling of the blanket? Yeah. A couple of the impressions, a couple of photographs of our factory. You can already see it looks like high-tech. It is high-tech. Everybody of you who will make it to Germany is highly invited to visit us there, to meet us there, to see how difficult it is to produce a printing blanket and what is involved in the steps. Talk about how difficult it is to produce a printing blanket. You can see here a little scheme, a little sketch of how many steps, how many different steps are involved in the production of a printing blanket, of offset printing blanket. I'm not going into too much detail at this point. I just wanted to show you how many steps there are. It's not just putting rubber and fabric together, bond it to each other, and ready it is. There's a lot more to it. My apologies to the Heidelberg people. That is coincidence. There's no tie with MAN or anything like that. Okay. The printing blanket is the main factor, the main transporter, if you want to put it that way, that brings the ink being transferred from the plate to the blanket, from the blanket to the substrate. So the blanket is the key factor to proper printing, because that is the transferring medium. Yeah. And as printing machines are evolving, as the entire process of printing is evolving that much, Heidelberg as well. Yeah. The printing blanket still does, and will always play this extremely important role. What does the printing blanket do? I already said as much. It is the indirect transfer process that the printing blanket is directly involved in. That's what it does. Doesn't sound too difficult, but it is an extremely difficult task. Did you ever think about how many dots you are transferring on a sheet of paper? We just did that little calculation. So in a 60 by 80 centimeter image area, with a 60% screen, you already have 3,600 dots per square centimeter. A tiny little square like that. Yeah? So on the image area, you have dots of 17,280,000. This is what the printing blank is supposed to transfer to the paper, to the plastic, to whatever you're printing on. The dot is not supposed to gain in size. The dot is not supposed to change the round image, the round shape. Yeah. This is all supposed to be done by the printing blanket. In 17,280 dots on a 60 to 80 centimeter image area. And all that at speeds at about, okay, for sheet fed, there's an example, 18,000 impressions per hour. And now imagine heat set applications where we are talking about up to 80,000 impressions. Yeah. What kind of load is on a printing blanket? Where do the printing blankets that we nowadays have do come from? How did they develop? A little bit of a back tour into history. Not that much of history, because some printers still use that technology. We're talking about conventional blankets. Conventional blankets do only consist of rubber and of fabric. Rubber itself is not compressible. If you compress rubber, it'll move sideways. Yeah? But the volume doesn't change. In a compressible blanket, that's a bit different. In a compressible blanket, the surface zone does not change. Come to that in the next one. This is a conventional printing blanket. The ones that have been used beginning of the last century, or that have been started to being used beginning of the last century. You can easily see it's the plate cylinder being pressed on the rubber blanket cylinder with a certain pressure. The rubber moves sideways and builds these bulges on the side. What does that mean? It means an elongation of the contact zone in printing. This is something you don't want because it's very hard to achieve a proper dot shape, a proper dot reproduction in that kind of situation. So you have to do a lot of adjusting with the packing, with the machine itself, to be able to get a proper print result with the old type blankets. Additionally, as there is no compressible layer, as the blanket cannot be compressed, it is very sensitive to smashes, for instance. Again, something nobody wants. You want a long lifetime of the blanket. A quick look at the current generation of compressible blankets. You can see this compressible layer, the layer with the blue dots in between. This is compressible. This is a rubber layer with holes filled with air, closed cells. And in this area, the blanket is being compressed. So you don't have this bulge building. The contact zone in your printing stays the same. Yeah? And this is something, for example, with pre-press people, they can adjust to. Yeah? What they cannot adjust to is changing properties, changing behavior in the press room afterwards. You will have a lot less of a problem with this type of blanket. I'm pretty sure most of you are using compressible blankets anyway. Still, it's always important to have a little bit of a look into history to see where it comes from and why it is they are compressible nowadays. Quickly, advantages and disadvantages of the different types. Sure, conventional blankets are excellent for solid printing. And they work quite well in packaging and the metal decorating industry. But the downturns of such a product, and there are several, you can see that risk of tonal shift, risk of shift of paper, shorter service life because of the low resistance to smashes, to double sheets, to anything like that. Yeah. Cylinder rolling. A lot more need to adjust with the packing, with the machine. Yeah. This is all something that can be avoided with the compressible blankets. I wouldn't say that there is no disadvantage in compressible blankets, we just didn't know any. Yeah. There are a few, for instance, at least nowadays, price issues. But in the introduction we already heard, why are you spending so much money for a high-tech print machine, and afterwards you waste all the possibilities that your machine offers in a simple thing like a printing blanket? No need. Let's have a close look at the product, at the raw materials involved in the blanket manufacturing. What you see, if you look at a blanket, and I'm pretty sure everybody has, you see fabric on the back side, see rubber on the top side. If you look at it closely, you see different layers. If you look even closer, or if you try to find out what it actually means, we are talking about in a 1.96 millimeter blanket, a 4-ply blanket, we are talking about as much as 4 different types of fabric. We are talking about as much as up to 4 different types of rubber. Starting at the fabric. The fabric is, again, a crucial part. Printing is a very sensitive thing. You see every flaw in printing. If you have a dusty press room, it will show in printing. You all know that. Yeah. The first picture, for instance, just shows how much effort it is to clear the fabric, the raw fabric, of each and every knot, each and every lint in there. Fabric is being washed. Fabric is being pre-stretched Because you want a very low stretch in the printing length on the machine, because otherwise, again, elongation of dots. We're talking about the constant need to retighten your blankets. We're talking about noise generation, and so on and so on. Yeah? So you want a low stretch, that's also being given by the fabric. Well, that's why all these steps are needed in order to prepare this fabric. We have the rubber compounds. As I said, we are talking about up to 4 different types. We have a adhesion rubber that sticks the several parts, the several fabric layers together. We have the compressible layer, the one with the holes in, which is a very special rubber. And we have the deck sheet. Several types that only need special care. The carcass is already, what other people call the substructure, is already a product out of this material. When 2 layers of fabric are being coated with an adhesion rubber and being doubled in a press, which is rolls, just pressing this material together, here, building up the substructure. 2 or 3 layers of fabric being bonded together. The compressible layer, really key factor to a blanket. This is where most of the print behavior is being generated. Most important thing, you want an even distribution of the cells, because otherwise you will have one large bubble in one area of the blanket. You have small or no bubbles in another part of the blanket. What does it mean in printing? You have different pressure situations in your image area. You want an even distribution. Yeah? This is something we have to take care of. The cover, or the surface. This is the rubber you are seeing. This is the colored bit. Little tip, little advice on the side. The color of the deck rubber is not responsible for any print behavior. It's still common knowledge, or it's still common belief, that a green blanket is printing better than a blue, and a blue blanket probably prints better than a red. It's not. I could give you a black blanket and print the same like a blue blanket. Yeah? That's just on the side. The cover and the surface, the image transferring bit. Yeah? Again, it's being spread on the carcass, on the substructure, on the prefabricated material. Yeah. And a standard, a normal surface layer has a thickness about 0.5 millimeters. To achieve that, the blanket passes the machine up to 50 times. Each layer of rubber building up this layer is only 0.01 millimeter thick. What an effort. What an effort just to get you proper print results. What happens otherwise? It could happen that bubbles build up. You have problems in controlling the surface thickness, and therefore the thickness of the entire blanket. Again, this will all show in printing. If the surface is being spread, or has been spread, the grinding takes place. All blankets nowadays are being ground. Factors in printing. Show the finishing and quality control, another matter. We don't have to go into too much detail there. Just one thing, there is by now no really good working automatic system. All the blankets are visually checked for surface defects. Again, a very time-consuming matter. Now quickly, let's have a look. We have gone through the production steps, what is needed to get a blanket together, from bottom to top. We're now going from top to bottom. How does it affect your printing? Starting at the surface. The surface, I already said it, is the transferring media for the ink. It's taking up the ink from the plate, transfers it to the paper. Yeah. So the surface is being responsible for sharpness of the contours, gloss of solids, contrast. The grinding of the surface is responsible for the QR effect, for the quick release of the blanket. You don't want the paper to stick, to adhere to the blanket. Yeah. Therefore, paper transfer piling. Ink transfer, again, same kind of matter. Yeah. And it's directly related to paper dust buildup, for instance, washability. What does it mean? For instance, if you have a rough blanket, paper dust buildup will be a lot less. But you will sacrifice print quality. Because a rough blanket cannot reproduce the dots as much or as good as a smooth blanket. Yeah. The cover, which is the entire deck sheet as a whole, as one piece. Yeah. This is where most of the resistance to smashes comes from, or resistance to the chemicals, to the washing chemicals, for instance. Yeah. Swelling. This is where the resistance against swelling from these chemicals comes from. What does it lead to? Embossing, piling, for instance. Yeah. The toughness against smashes directly comes from the hardness of a blanket. Hardness directly relates us to another issue. How many people of you have been asking your blanket supplier, your blanket dealer, for the hardness of a blanket? Almost everybody, I would assume. No? Was there a no? Okay, fair enough. You should. The hardness of a blanket cannot be measured because we're talking about a 2 millimeter sheet, yeah, that you're trying to measure. Hardness is being measured by a needle, yeah, being put onto the surface, and then you read, yeah, the penetration of the needle. You're measuring that on a 2 millimeter thick material, on a 2 millimeter thick sheet. You will always measure the table as well. If you have a soft table, you will have a soft blanket. A hard cover is good against smashes. A soft cover is good for good dot reproduction. Just that on the side. Because now we're coming to the substructure, and the substructure is exactly in the opposite way. You need a soft substructure to have good resistance to smashes, to double sheets, these kind of things. But you need a hard substructure for good dot reproduction. We're talking about a contradiction here. Yeah. And now imagine measuring the hardness of a blanket in the blanket itself. You have a hard surface, a soft substructure on one blanket, and you have it exactly the other way around on the other blanket. The reading could be the same. So whenever you ask for hardness, ask your dealer, ask your manufacturer of the blanket, how hard is the deck layer? How hard is the substructure as such? How hard is the rubber within the substructure? That will give you an indication. The overall hardness, not at all. The substructure also is responsible for absorbing all other kinds of pressure peaks, is responsible for all problems in setting up the machines, adjustment of the machines. Yeah, that's a lot more crucial in non-compressible blankets. Yeah, this is where this behavior comes from. Also in the substructure we find all the fabrics, all the fabric layers. The fabric layers are responsible for the strength of the blanket. Tensile strength, elongation. Again, I was talking about 4 different plies of blankets that you're bringing around the cylinder. For instance, the lower fabric is traveling a shorter way around the cylinder, like the top layer. You need different types of fabric. We've been talking about the elongation already. Elasticity is basically the same. Yeah, you want a certain elasticity to achieve exactly that. You need more elasticity on the top fabric layer, less on the bottom, because otherwise it's just going to break on the bottom part, on the top part. What could it lead to, or what does it lead to? Some of your problems in your press room may result from the blanket, such as slurring, horizontal slurring, doubling, elongation of the dots, shifting of the dots. Could all be related to the blanket, but not necessarily. But this is all something that you can mostly adjust to. That is something that you can adjust your machine to. That is something you can adjust to just by handling of the blanket. Again, just a couple of images how printing problems do show in the printing. We have light printing, we have dot gain, we have too much contrast, all these kind of things. Yeah? Could come from improper blanket adjustment, improper blanket handling. Not necessarily. Printing blanket could be the source of all that, but doesn't need to be. This is just to show you how much steps are involved. And all these problems could originate from any kind of point within the chain. Coming back to the printing properties again. We were talking already about quick release, about quick releasing blankets. Especially in the web fed industry, in the cold set and the heat set industry, it's very, very important to have a quick releasing blanket. Because otherwise, the blanket will not follow the ideal line, which is here shown in the black line, but will stick to the cylinder and will follow the red dotted line. And this is what it leads to. Especially showing in the last picture. If you have a neutral or decelerating blanket, a blanket that is not good in quick release, a slow releasing blanket, you will probably have the problem of a breaking web. On the other hand, if you have an accelerating and in combination a neutral blanket, you will have paper buildup in between your print units. This is also the reason why you should avoid it to mix different brands of blankets on your machine. Just not advisable for exactly this reason. Printing blankets do behave differently, although again, they all look like floor mats. But as I've shown you, there's a lot of steps, there's a lot of factors involved here that make a printing blanket. And that's why every printing blanket is different. Embossing and piling, we're talking about the surface again. You know how it looks like. You must have imagined, or you must have come across these problems several times in your own press house. Smashes as well. If you have a bad quality paper or a badly adjusted paper feeder in front of your machine. This is a real blanket killer. Again, you know that a lot better than I do. But you can do a lot as well to prevent this from happening, and also to extend the lifetime of your blanket, to improve your print quality. And this is the handling of the blanket directly. Yeah? Just browsing through it quickly. Most of you will not be connected to the handling of the blanket, but you can have an eye on it. Are your blankets stored in the right way? Yeah? Most of you will have cut-to-size sheets. Are they piled up in a corner, up to whatever, half a meter high? Here, face to top, or face to bottom, you will probably encounter fabric marks. If you store them face to face, back to back, no problem anymore. Yeah. If you have rolls, or if you have blankets in roll form in your warehouse, store them upright or hang them, because otherwise, again, will damage the blanket. Very simple things. The packing. You can talk about the blanket all day, sure, but the packing just underneath it is a very crucial part as well. This is what builds up the pressure on the blanket. Here, if you pack too much, the pressure on the blanket will be very high. Apart from the factor then that your print image, yeah, will slur, will not be the same as it should be. Yeah, you shorten the lifetime of the blanket as well. So usually, what most press manufacturers recommend, if you pack up to 0.1, 1.3, 1.5 over barrel height, you're on the safe side. Most people don't even measure. Have an eye on that. It'll extend the lifetime of your blanket. The mounting of a blanket. Whoever has punched blankets here and is punching itself, you're probably using used blankets. Used blankets have elongated holes, have elongated punches. It'll be very difficult to get a proper punch in there. Use a new one, use a template. Easy matter. Yeah. Make sure that the blanket is being cut in a 90-degree angle. If it's not, it's being mounted on the machine in a slightly diagonal way. Imagine what happens with a blanket. You have a lot of force on one side, and it's very loose on the other side. How that shows in printing. And the old problem of over-tensioning. Most people use a simple spanner to mount a blanket on the machine. But how do you know that the blanket is being mounted correctly? A blanket has a strength of around 4,000 Newton meters before it breaks. The measurement of the sinking loss in thickness when being mounted is being measured at 1,000 Newton meters. But the blanket is only being mounted with a force of 50 Newton meters, preferably. None of your press operators has such an exact arm, such an exact force in his arm to make sure it's correctly mounted. Simple thing to avoid that, use a torque wrench. This again on the mounting. Yeah. The washing, coming back to the surface. What does the washing do? The washing opens up the pores of the blanket, removing all the lint, removing all the ink. But if you use very aggressive liquids, very aggressive washes, yeah, these washes will open up the pores too wide, and these pores will not close fast enough. You start your printing again, and all the chemicals you are using, all the ink you are using, can penetrate into the blanket, and the blanket will start to swell. Again, something everybody knows. Everybody's trying to avoid. The very simple thing is, stop using benzene, stop using kerosene. Use a proper blanket wash. Most of you will say, but I'm doing that already. Have a look at your print house. Have a look at your press room. I've been to quite a number of places where the press manager, where the general managers were fully aware, absolutely confident, that his guys are not using any aggressive materials. You walk down to the press floor, what do you see? All the bad stuff. Apparently we don't mind you using that, because we sell more blankets this way. Yeah. But you probably want to keep the blanket a bit longer on the machine. What it also does is it hardens the blanket. In the blanket, you have softeners, rubber softeners. Aggressive washing agents. Again, open the pores, and they spill out they bond to the softeners here and take them out. The blanket gets hard. The blanket gets glazed off. Again, a very easy thing to avoid. Use proper washing agents. This is just a quick look at how the handling could relate to problems in your printing, such as wide areas or light areas in your printing, yeah? Which could have something to do with too little pressure on your machine. Yeah? But it could also be a loose blanket. It could be a blanket being over-tightened, because a blanket being over-tightened loses thickness. Again, losing pressure, and the ink transfer is not correct anymore. Yeah? Filling in, doubling, slurring. Same thing, only opposite. Yeah? You have excessive pressure. Again, use a torque wrench, control your packing, and you'll be on the safe side. At least if it comes to the blanket. Bar marking, again, has very widely spread something to do with over-tightening of the blanket. Yeah. Again, edge marking, embossing, piling, yeah. Something to do with wash cycles, with the washing agents you are using, with the state the surface layer is in. To wrap this all up, this was a lot of information on something seemingly unimportant, looking utterly boring. But this material, the printing blanket, is majorly involved in the result you are having in your press room. If the blankets are being treated right, you can improve your print result by far. You extend the lifetime of the blanket, although we don't like that. Yeah. And that's just by implementing very simple, very easy steps in your process. And this already brings us to my end. Thank you for all your patience, for your attention. And if there's any questions you would like to ask, feel free to shoot. I think we have a question over there.
On the mic. I'm from ITC. Okay, we are paperboard manufacturers. Okay, we supply the offset press for packaging applications. Okay, general complaint that comes from the printers. That's model. Okay, patchy printing and
Yeah.
that's a thing. Okay, I want to know from the blanket side, what are the possibilities for a model and how do we overcome? One. Second question is, the life of the blanket, does it have any relation to the substrate use? Okay, the quality of the paperboard use. Would it increase the life of the blanket or would it decrease? Can it damage? And the third one is the blanket that you use. Do you have any animal skin or something used in that? Or is it 100% natural rubber? Thank you.
Okay. Okay, about the modeling from the blanket side. Yeah? As already indicated, there could be several several factors influencing that, yeah? Such as the softness of the blanket. Yeah? And softness of the blanket also already means how is the blanket being mounted on the machine? Is it being mounted in a complete or in a correct 90-degree angle? Yeah? Because if not, you will have slack on one side, over-tensioning on the other side. Yeah? There is the matter of washing. Already indicated that. If the washing agents are too aggressive, yeah, in the first step, this will soften up the blanket. Yeah. Later on, it will harden it, but in between, the blanket will have a certain softness to it. Yeah. This is just two things that play into account here. To have proper judgment here, we would need, or somebody would need, more information on the scope. How does it look like? What kind of other factors could have been playing into that? Yeah, it's always very hard to answer or to give a proper solution for this kind of question. But that is two things somebody could start with. By the way, that's the man who never asked his blanket supplier for the hardness. Your second question, that was, as far as I know, the one on the substrate?
The life of the blanket.
Okay. Yeah, okay. Directly linked, no doubt. If you have bad paper quality, yeah, you have the danger of having bent-up sheets, of having double sheets getting into the machine. Yeah. If you have poorly cut edges, yeah, the tendency for edge marking in a blanket is a lot more. Thirdly, if you have a lot of paper lint on your paper, yeah, the need for washing the blanket is a lot higher. And the more you wash, yeah, the more you influence the blanket. Washing is needed, no doubt, but overwashing, again, kills your blanket. And there it doesn't matter what kind of wash you're using. Whether you're using kerosene, a good blanket wash of a renowned producer, yeah, too much washing will shorten the lifetime of your blanket. Yeah. This the three factors in paper. Sorry, your third question was?
Any animal skin used in the blanket?
No. The fabric is cotton, and the rubber is a synthetic rubber. No animal parts whatsoever.
I think you're cow blankets, right?
I'm not even sure about the cow blankets, but I believe it's also only rubber and fabric. Did they tell you that they are using cow skin?
I'm not a printer, okay?
Oh, yeah.
I have a question here. Can you throw some light on underlay blankets and how important they are?
Okay, yeah, sure, I will try. Underlay blankets do add compressibility up to a certain amount to your entire setup. That is one thing. Secondly, underlay blankets are only being used in old machines anymore. The new machines, yeah, are usually only packed with calibrated paper or sticky back foil. To make it a bit easier to add underlay to add the amount you need, use underlay blankets because they are being delivered in standardized 1 millimeter up to 1.3 millimeter thickness. If you try to add that up in paper, it's a lot of paper you're using. Yeah, but the history of that is again from the incompressible, from the conventional blankets, because there it was needed to add a certain softness to the entire structure. That's why these rubber blankets and these rubber underlay blankets have been used in the past. There's no technical need for them anymore. If you can pack that in paper, if you can pack this amount that you're needing in foil, go for it.
Yeah.
A commercial printer would have many different kinds of jobs. It could be a solid job or maybe with lots of highlights or maybe with lots of tonal variation. You said a harder blanket would be better for solids and a compressible blanket would be better for dots, a proper definition of a dot. Now, as a commercial printer, how does a printer select a blanket? Because he may have to run an art paper to an uncoated paper to an board. How does he enhance the life of the blanket in such a situation?
Okay. There's two different approaches. If the printer is willing to use separate blankets, yeah, then there is a separate blanket for each job. And that certainly enhances lifetime. On the contrary, if they are using, or if they want to have perfect dot reproduction, and they are using a blanket for that, and the next day they are using cardboard, whatever, probably even a smaller size, yeah, that will shorten the lifetime of the blanket because such a blanket is not made for the packaging purposes or for the purposes of such substrate. Yeah. So for the next job, you will have to take another blanket that is a lot tougher, yeah, but is not as good in dot reproduction. We are talking mostly in high-end blankets about minor differences. Experts will see it, other people may not. Yeah, but this is the most perfect way. On the other hand, there are certainly all-round blankets. Blankets that offer a good compromise between the properties. Yeah? Without sacrificing anything of the lifetime, but also without sacrificing too much of the print quality itself. So this is the two approaches to adapt to different substrates, and therefore to extend the lifetime of your blanket.
You've just said blanket is mainly comprising of rubber. Now, when we are talking of a blanket for a particular machine, it's normally rectangular in size, and you tension it from both the ends. Now, when you go in for a large format, the size of the blanket gets bigger. Now, what is the correct way of tensioning it? See, what happens is rubber expands on all sides. Now you are tensioning it only from the circumferential leg. What happens to the exactly cross-diagonal ends? Do you have any answer for that? Because normally, apart from the pre-punched blankets, normally in India we have blankets which do not come pre-punched. So punching is done at the press. How do you punch them and how do you tension them? Could you throw some more light on it?
Okay. Coming back to the punching, what I said before, yeah. If you do punch your blankets yourself, you should use a template made of steel, made of wood, whatever, a non-changing material. Yeah. And not an old blanket that you've just been taken off the machine. Yeah. Because in such a blanket, or with such a blanket, you already have elongated mold because of the tension that you applied to the blanket. Yeah. You've been asking about the change in width of the blanket, or the possible change in width. There should not be any, because the tensile strength or the elongation, yeah, that is being, or that can be applied in running direction is only about 1.2% maximum. In that range where you are tightening, where you're tensioning your blankets, the width of the blanket should not change at all.
I'm more interested in the large format presses. I'm not talking of the small format presses.
Yeah.
In a very large format, say 74, 102,
Yeah.
size. So the rubber which is there, it should elongate. Ideally, it should elongate on all sides, you see. But when the tensioning is done, it will elongate on circumferentially, but there will be a slight, at the cross ends, diagonally. How do you counter it? And normally, we punch the blankets according to the punch bars, not with any templates or not with old blankets.
Okay.
Because that is on what we are going to mount it on.
All right. Okay.
Yeah. So how do you overcome this sort of? There has to be some percentage of very, very minor, but there has to be some percentage of elongation of the blanket.
Okay, as I already said, the elongation of the blanket, in running direction, is limited to usually about 1.2, 1.5%. This elongation in running direction is very little, because you don't want to retighten all the time. Secondly, you need that bit of flexibility, of elongation, in order to bring it around the cylinder. Yeah? If you don't want any elongation, you would have to use steel, something like that. That print transfer, different story. Yeah? In order to in order to get that elongation evenly spread, you usually start to tension your blanket on the outside, work your way to the inside. Yeah? Because then you will not have any change. If you start from the left-hand corner, go to the right-hand corner, the blanket already shifts. Yeah? That is why you usually start tightening from the outside, working your way into the inside. Yeah? And then you should have a proper set of the blanket on your machine. Answers your question?
Well, partly, not fully.
Okay.
Well,
We can talk about that in detail later if you like.
one question here.
Yeah.
Can you give us printers some salient features when we choose a blanket, what we should exactly look for?
Look for a good blanket.
Yeah,
How do you know what the blanket is?
Yeah, that's right.
You have to try it. And this is a very, very important part. There is no best blanket. I could tell you now that we are supplying the best blankets, and I would be lying to you. For some of you, we might be supplying the best blanket. For others, they are probably not even suitable for their application. Yeah? If somebody of our competition comes up to you, telling you, our blanket, perfect thing, best ever, it might not run on it. Yeah? And this is why this question cannot be answered. You look for a blanket that fits to your application. This is something you just have to talk to the salesperson about. But your final decision can only come from trialing the blanket, from testing it under your very own conditions in your press room.
You mean to say we have to take a practical trial, and that is the best way to choose a blanket?
Unfortunately, yes. I would like to sell the blankets in a lot easier way, but it's simply not possible.
Okay, thank you.
Anybody else? All right. Then again, I thank you for your patience.
I have a question.
All right.
You have suggested, Thomas, that whatever you use as a wash, be careful of that wash. Can you give us a pointer of, because there are so many sorts of washes available in the market, what should a printer be wary of in a wash? What particular chemical that nobody suggests? If you can just give us that pointer, we would be more careful.
Okay. First thing, you will probably have a problem with finding out what actually your blanket wash contains. Yeah? Nobody will give you a very detailed description of how they do their blanket washing. Yeah. There is blanket washes for certain applications, for different applications. You run conventional inks, do you run UV inks, all these kind of things. Yeah. This is the first thing you have to follow. Use the right blanket wash or the blanket wash for your application. There is universal washes, sure, there is. If you want to have a very good result, if you want to use as little wash as possible, yeah, go for a specialized wash. In general, we have done a lot of trials, sufficient trials with several products, several manufacturers. There are differences in the tendency to make the blanket swell. There are. But in the end of the day, they are minor. Yeah. So again, a blanket wash may be better for you. You'll be happy with it. Yeah. Another maybe not. It's again about trialing. It's again about how your printing process is being set up. We've been talking about paper qualities. If you run a lot of bad paper, if you have a lot of paper dust buildup, you do need an aggressive wash. Then you will have to use one, shortening the lifetime of your blanket, or you decide to change the quality of your paper. Yeah. If you don't have to use such an aggressive material, you use something lighter. Yeah. Again, as sorry as I am, there is no universal answer to this question. It depends, as so much in printing, on the conditions that you have in your press room.
Thanks. Thanks, Thomas and Rajiv. We will all remember that blanket, please do not treat it just as a floor mat. Thanks. From the BMPA, I would like to, Uday Dote, will you please hand over a bouquet of flowers and a small memento to Thomas P.
Thank you very much.
Thank you to Rajiv. Our next session will be conducted by Tushar Dote from the MMP.